Hello again. Today we start our next lecture on digital design course. The topic truth tables and Boolean functions. A Boolean function is described by an algebraic expression consisting of binary variables, the constant 0 and 1, and the logic operation symbols. For example, we can write function of A, B, C equals A and not B, or A, C. Function 2, X, Y, Z, B equals X not Y or Z not B. As you see, we have logical variables and logical operators. There are different ways to express a Boolean function. Algebraic expression, as I mentioned, if A, B equals some Boolean expression, A not B or A, B, for example, by means of a truth table. A truth table, in the truth table, we list all the variables. For example, if we have a function, if A, B, C equals to A not B or B, C, then we have three variables, A, B, C. We list all the variables. We have here 8 states. And 1, 1, 1. And the value of the function for each state. Here the function f is equals to 1 when A and not B. A and not B. These two cases are 1. Or when B and C. B and C here 1 and here 1. And in all other states, it is equal to 0. Here 0 and here 0. If we have n variables, then we have 2 to the power n different states in the truth table. And the third method by means of logic circuit. For example, the function ABC, here we have A, B, and here B and C. So this is the function or gate F. These three forms are equivalent. We can derive the function from the truth table or vice versa, and we can from the function draw the circuit, or from the circuit we can obtain the function. Next, how to derive a function from the truth table. For example, we have the following function f given of 3 variables, and we need to find the function A, B, C. Do you see it is equals 1 here when A in the complement form, B in the complement form, and C in the normal form. So we write A, not B, C, or, and 1 here when A in complement form, B, not C, or here when A, not B, not C, or here A, not B, C, or here A, B, C. Do you see we can simplify the function in order to implement it? If the function is given in this form, in each term, all the variables are included, either in the complement or in the normal form, then this form is called standard form. And sometimes it's called canonical form. And we will come to that in the next lectures. Next, what is the number of functions that can be generated using n variables? If we have n variables, so we have 2 to the power n states in the truth table. Now, for the states, we can generate 2 to the power 2 to the power n different functions. States. For example, if we have 2 variables, here write number of variables, number of functions. If we have 2 variables, then we have 2 to the power 2 to the power 2, 16 different functions. If we have 3 variables, we have 2 to the power 8 equals 256 different functions. If we have 4 variables, we have 2 to the power 16, which I think 65,000, 6. You can calculate quickly. This is 2 to the power 10 multiplied by 2 to the power 6, 64 multiplied by 1024, etc., etc. I'm going to list the functions for 2 variables. We do not need to list the function, all the functions in these states, but you will know the logic, how they are expressed. We have 2 variables, as you see. In the truth table, we have 4 states, and now we have 16 different functions. Function 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, and 1, 1, 1, 1. These are the 16 functions that we can generate using 2 variables. First, you note that if 0 is equals to constant 0, constant 0, because it is 0 in all the states, regardless of the values of x and y. And if 15 equals constant 1, because it is always 1 regardless of the values of x and y. And you know that f0 is the complement of f15. And f1 is complement of f14, f2 complement of f13, etc. And f7 and f8 are complement of each other. Now function f1 equals to 0, 0, 0, 1, and you know this function, it is x and y. Function f14 equals x and y or not, or according to not x or not y. Here 14, x, y or not. Really, you could find f14 from the truth table. F14 equals to 1, 1, 1, 0. Not x, not y, or not x, y, or x, not y. These two terms differ on y, so we can write here not x, or, and these two terms differ on x, so we can write not y. Next, f2, function f2 equals to here x not y. And we cannot simplify furthermore. F13 equals x and not y or not, which is equals to not x or y. Not x or y, or x and y, x and not y or not. Let's see. Next, step 3 equals to 0, 0, 1, 1, which is x directly. And you can see that f12, 1, 1, 0, 0, not x. And really you can 0, 1, 0, 1, this is the function f5, y. And 1, 0, 1, 0, here f10, not y. Regarding f4, 1 here on not xy. So f11 equals not xy or not, or x or not y. Here, not x, y or not, or x or not y. Now, regarding f6, 0, 1, 1, f6 equals 1 here and here on not x, y, or on x not y. And you are familiar with this function. It is exclusive OR function. X exclusive OR y. We cannot simplify this expression furthermore. Now regarding the function f9, it is the complement of f6, or x exclusive or y or not, we can write like that. Or really it is f9 equals 1 on not x not y or on xy. And again, we cannot simplify this expression furthermore, and this is the equivalence or function. And again here, x exclusive or y or not, like that. F7 is the or x or y. And f8 is the nor x or y or not. And x, the nor, you know, equals not x and not y. So these are the 16 functions that we can generate using two variables. For now, thank you.